So they call programming languages language for a reason. The reason is that you have to learn it as how you learn any language if you are new to it. So if you take a typical language, you are able to record, apply this into future requests. Okay. Yes. So if you look at the language, basically a combination of alphabets that should make sense to the people who are also familiar with the language. So if we both speak the R language or both speak the Java or C or C++ language, when you read a code, which is basically a written document in that language, we should be able to understand. And whoever is new has to take baby steps to understand. So it's usually difficult at the beginning, but with time, consistency and practice, you start to get better at the language. Just as we all started learning to speak our various languages. So the name of the programming language that we want to use is the R. That's just the name. There's another precursor to R, which was the S, which is not a free source. So back in 1992, these statisticians wanted to have an easy-to-use software for their students to undertake statistical exercises, and they were, as you like, hit with the paywall. So they decided to find a way to get them to use a free version of the same or similar software. So they created the open source version of S, which is R, and has become a very popular and common tool since that time. So as a base, as an open source tool, there should be a team that maintains it, and we call that team the R development core team, which is a few people. But I indicated to you earlier that there's contributed packages. And that's how open source tools work. There's a huge body of people who contribute to the functionalities to the software. And those are mainly volunteers who continue to maintain the software. And that's very much the case with R. How useful and how popular is R? Is it of any good use? Here's a few examples from companies. And they may use them in different specific ways, because the open source softwares like R and Python are very versatile, so you can incorporate them into different activities in the business. So this is a number of companies that use them. There's a lot more if you look at that which use them, and you can see that they are from different areas. You have automotive, you have pharmaceutical, you have travel and you have news agencies, accounting, finance, banking. So you see that so many uses of R can be made depending on what the specific is. And that's also the beauty of open source. Once a contribution is made along certain lines, anyone who is interested in making use of that can pick it and continue from there. So this is how the R looks like. This is the interface. We will use the integrated development environment called RStudio, which is now POSIT. That's the one we use. That looks more like this. It is more interactive, especially for non-programmers. It's more appealing, unlike the blank page of R or the original console. So this is what we are going to use. If you have installed it and you started it, you must have seen an interface like this. So earlier, I've already indicated to you that R is a free software. And free here means free. So it was originally for statistical computing and graphics, but now, because of contributions, there's a lot more than that, especially for data analysis in different fields. It's also used for data analytics and machine learning, as well as artificial intelligence tools. So that's all other uses as the contributed packages allow can be done with R. Now, to be able to do an expansive work, there are what you call packages. R package is just code and data, and the package will contain functions that perform specific tasks based on the need and the purpose for which the package was prepared. So we have the base packages. Those are the ones that you use, and they are available once you install the R software. You don't need to do any extra work. some basic additions, subtraction, arithmetic, basic statistical estimations. All of them are available to do without an additional effort from external packages. But we also have the contributed packages, which are stored in the comprehensive R archive network. And these are the ones that are maintained by volunteers. I think as of 2013, there were about 6,800 contributed packages. As of, I think, 2021, there were about 19,000 plus contributed packages. As of yesterday afternoon, there were 21,145 packages. So that shows you the pace at which contributions are made to the software. So it has a very vibrant environment. That also means that if you have challenges, there's a wide community of users that you can get help with. You may look at forum like Stack Overflow, GitHub, R-bloggers, all those communities provide support that you may find useful as you go along. And that's one beauty of open source. So the packages are also organized into task views, basically topics or fields of study. So you may have economics, econometrics, sociology, psychology, engineering, all of that. And as you read along, you may find specific package that will be useful to you, or you can glance through the task views and read about some of the tools, some of the packages available that you may use. As we go along, we'll look at some of the links and see what are there. So as a typical programming language, you expect to see codes. So when you take a very complex code, which in this course we will not be bothered with, but the packages that you use are made up of complex codes that are basically these objects coming together. And while you will not be writing those complex codes, the uses of the packages will require that you follow some basic rules to make good use of the packages. Then one rule that you have to note is that R is case sensitive, and that's very important. It means lowercase and uppercase are important. For example, mean, depending on how you write it, will mean different things. Like learning any language, how you need to write them in ways that make sense to those who are native or abreast with the same language. So case is very important. Punctuations are also very important, which we have to note. Otherwise, you run into a lot of errors. We also need to make very good use of what you call assignments. So if you look at this line, realize that we have assigned a sequence of numbers from 1 all the way to 500, increasing by 0.5. That's what it means to UU. In some cases, the equal sign is used, which is not the best in some sense. So we have to assign most of the time, which is very useful, because if you are going to work with large data sets, you don't want to split your data set on your working environment. So it's good to assign so that you can take a look at parts and portions of the data that you want. And in assigning, there are a few things that you need to note, that you don't start with a numerical character, but you can end with numerical characters. And there are a number of basic or base functions in R that you don't want to assign your objects to or create your objects with that name. So like mean, pi, sequence, square root, these logical operations, etc. You don't want to assign your variables to them. In fact, they will cause a lot of problems for you. The other thing that you also have to know is, in most programming languages, there is the need for comments. So you want to write either statements or explanations that should not be seen as code. So in R, the hash sign is used to comment. So you may have a code that you don't want to make use of in the current situation. You just put a hash sign on it to comment them, so that you don't get unnecessary outputs or you don't get errors for running lines that are not codes. And for purposes of being able to look at your code or sharing with someone that makes sense, comments are very important. And spacing out of your codes is also very important. For replication purposes, always to make your codes very readable. One of them is to space them out. So from a very non-technical point of view, this is how I introduce R so that we can make use of it. There will be other things that I will show you along the way. And as we break into the rooms, there are others that you also look at. And as you interact, you find new ideas and new things to do. So this is just an example. We will look at a script. A script is basically a file with R codes that we'll go through and see how they come out. So we can use arithmetic operations. And what you realize that in the first line, only adding 1 and 2, everything else after the hash sign is a comment. If you remove the hash sign and run, there should be an error because that statement is not code. R doesn't understand it as a language. We saw these expressions also from the code snippet we showed earlier. We have multiplication, subtraction, we have powers, divisions, and some built-in base functions in R. This is square root, and this is pi, the pi that we all know from our various algebra backgrounds. We can also combine a number of operations and get our results. One thing that I want us to note is this semicolon sign, okay, because sometimes you don't have to have too many lines of code, so we can execute a number of lines or codes on the same line, and we can separate them as many as they are with the semicolon. We talked about the fact that R works with data, especially because it's a statistical tool originally, as well as a graphical tool. So data has to be the oil that fuels the function of the software. And for quantitative decision making, you always have to make use of data. And you may use data by entering the data into your workspace or getting the data from an external source and just load it down to type the data, enter the data. And once you load it, you can sort of clean it, manipulate it to the way that you want it. So if you have a typical example like this data, you may want to enter it into R in this way. We'll look at them, but I just want to give you an idea of what is being done here. So we'll create an object called age. Then we'll assign the data corresponding to age based on our scenario. We'll assign all the ages to an object which we call age, and we will see that this is how we assign the age, and we have about 8 of them, so we want to number them by a sequence of 1 to 8. And we also create an object called height based on the data and assign the data for height to them. One other thing you need to know is that R basically looks at objects as matrices, data frame in a typical data table, if you like. It's also, so we can have parts of a matrix. You can have a vector of a row of a matrix. You can also have the column of a matrix, which are basically vectors. So when we do that, we can put them together as one, and we can use the data frame function. So far, I realize that we are still using the base packages in R, and we assign the table or the matrix or the data frame. Later, I realized that the matrix itself, in terms of data type, is different from data frame. Here we are using the terms loosely. So we assign that data frame or that table of height and age and the numbers of them to data. After that, we can look at them by looking at a few things. We can look at the top of the data, the last part of the data. We can look at the dimension. If it's a matrix, it has to have rows and columns. We can look at the dimensions, or we can look at the table itself, and we use the view function to do that. You realize that the view here is V is in capital, not small. That's one of the case sensitive issues you need to look at. You can also look at the structure of the data using the str function. Once the data is done, once the matrix is set, we can look at different aspects or parts of the matrix by using a number of approaches. We can look at the specific location of the object, or we can use the names, or we can bind them together. So all of these, we'll go through them. I just want to give an overview of that. So working with data so now you're not going to enter the data. You may have the data sitting on your desktop or in the directory, the working directory. So In R, when you start your R session, there's always a default working directory, and that is your documents, which you can change because you don't want to be writing all your files to your documents or putting all files in your documents so that you read them from that side. One of the basic skills that you should be very familiar with is changing working directory. Because if you're working on a project, you want to be moving from one folder to the other. So changing directories is very important to know. And there's a function called the set working directory. So if you look at the set working directory changes, we just need to put the path to that folder into the working directory, into the set working directory set wd function, in quotations, of course. Then R does not know how to read the Windows path. So the Windows path is \, so you have to change all your paths to /, or you double the backslashes. And that's how R understands. If you do that, you can go back and check with your get wd to know if you are in that directory. There are other things that you can also do to see if the files that you expect to see in that directory are there. And that also tells you whether you are at the right place or not. And one thing we want to look lastly is the packages in terms of the introduction. So packages, apart from the base packages, you want to work with added packages. And most of them are stored in the comprehensive R archive network. And the function to do that is the install.packages function. So if you look at the first one, it's install.packages. We stress the need for case sensitivity and punctuations. Okay. So there's small I, not capital, and there's a space, there's a dot in between, and there's packages, not package. So, but you will get used to it as you go along. You can put the quotation and enter the value of the name of the package. So this is just an example. If you are working, you are reading, you may stumble on the package that you want to use. The name should also be very case sensitive as you enter them. You can go into the task views and install some packages. So just as the software, somebody said they have downloaded the R software or the RStudio, but they have not installed. Okay. So it's much like the same thing. If you install a package, it is sitting on a library on your PC where your R folder is installed. But you need to use them in your current R session or workspace. And the function to get that is use the library and the name of the package. So now once you do that, you are making use of that. And all the functions and the data in the package are available for you to use. So there are two ways you can use the library function or the require functions. They do the same thing. So when you are installing from the CRAN, we said it's a body of volunteers. So there are different what we call locales where the packages are maintained. So you'll be prompted to choose which CRAN. You may have a preference, but you can always choose the default option so that based on the location and your internet connectivity, there will be an optimization of which package is best for you and it will be installed. Now, mind you, all of these installations should be done while you are online, so you have internet connectivity. Okay. And it's good because once we are on here, it means that we have internet connectivity. But not all packages that we may need are in the comprehensive R archive network. You may know the GitHub website. Some packages are also there, but we need to be able to make use of them. And you realize that has a slightly different function, the install_GitHub. It's a website with users where people post codes and other materials. So you need the username of the owner of that account, and you put the name of the package there. That will install the package for you. But again, that also requires another package before that can be done. So if you know how to install the packages, the dev tools. It's actually dev tools should be able to do that for you. So if you go through these, we will be ready to make all other estimations or analysis so that we can make our decisions. So that's by way of the brief non-technical introduction to R.